I'm starting the stream. Hello, this is going to be chill maths, I think, probably. Although, look what I found. This has been an absolute disaster for me getting anything done. Look at this. You can probably work out what's going on just from what's on the screen if you haven't already seen this website. But oh my goodness, it's a real productivity sink for puzzly sort of people. Hello, Maths 222222. Let me tell you what's on the screen. Hello, Mary. Good to see you as well. Hi, everyone. Here's what's on the screen. It's these puzzles that you might have seen before, where you get some numbers, and that tells you how many squares there are supposed to be in that row or column. So 3, 1 means that there is a section of 3 consecutive blocks, and then some unknown gap, and then 1 block. And you're supposed to use those clues to work out where all the blocks go. Yes, so something we might do is see 3 and 1. Well, there's an unknown gap in the middle, but there's only 5 squares total, so it must be 3 like this and then 1 like that. And I have lost an extraordinary amount of time on this website, which has all of them. All of the ones with a unique solution. There are 24 million of them, almost 25 million. And the thing I love about the website is that this is a list of 24 million of these puzzles, and it's collaborative. So all of them are here, all 24,976,511 puzzles. And as soon as you solve one, it's solved for everyone. So it's kind of a bit like, if I solve this one, then no one else has to ever. That's just it done. It'd be fun if I got it wrong. There we go. Okay, good. So that one's done now. And there's this counter which goes up by 1. I just lost so much time to this website. I sort of think it'd be quite nice for Twitch, really. Twitch is supposed to be about games, right? And this is sort of a little bit like a game. It's got some, I've been thinking about this. Like, it's got the thing that people like on the internet of clicking really fast and, solving puzzles. Yeah, good. You got ads. Sorry, Mean Machine Rex. And hello to Maths 2222. No, I already said hello to you. I'm sorry, that was quite mean of me to retract the hello. So I am going to do a quick experiment to see if I can do this as a streaming activity or not. 2 hellos. Yeah, it's too many. It's because you put 2 things in chat. You put your hello and then you put something inscrutable about 249 factorial, which I haven't decoded. Oh, am I stuck? That would be a fun thing to do. No, that 4 means that there's a string of 4, and then this 1s means that this one is not part of a string of 2, so that's, I can put across there and across there. I thought this would happen. So it's collaborative. And what you'll notice there is I was halfway through solving it, and then someone else solved it. Right, great. Yeah, they're a bit like Sudokus, aren't they? They're a bit like Sudokus. What's the difference? I suppose with Sudoku you have to fill in the numbers, but you still have those rules about the rows and columns. That's a kind of core element that's the same on both. Right, so I've learned I have to solve things pretty quickly. Right, purple is somebody else. So we're going to go over here and we're going to try and solve this one really fast before they change their mind and come and steal ours. You see? So we got that one. I'm orange on my screen. Right, yeah, no idea who that one was. So I sort of thought that this might be quite a good Twitch game in some sense. I have some sort of advantage in that if I'm focusing, I can do these quite quickly, possibly so fast that anybody who's stream sniping and trying to guess which one I'm going to do next might not be able to guess fast enough before I've actually done it. I have thought about this a tiny bit. Sort of thought, what's chat like? Is chat going to try and steal my puzzles from me while I'm solving them live on stream? I see I've got a poor start there, so there's clearly time for somebody to swoop in and do the steal. So I take that 2. The 2 1s are a bit tricky to think about. And then I'm now just stuck, aren't I? So 2 on the left, 3 in the middle means that one's there, and then the 2 on the vertical. So I've got this 2 1 2 1, and then I've got 2, and I've made a mistake because I've rushed it. That sort of thing, right? That sort of thing, where in some sense it's a nice Sunday afternoon solving some puzzles, but also with an element of jeopardy of, it's collaborative, but also a tiny bit competitive, because once it's solved by somebody, it's solved for everybody. I am a bit stuck. Oh no, so I can put that 1 in there, can't I? And then the 4 down there. Good, right. Is it a competition? I hope not, because I'm sure there are other people who are much better at this than me and much faster. So I sort of hope that it's one of those things where when I'm losing, I can't talk at the same time. I can't talk at the same time. When I'm losing, it's collaborative. There, and pop. When I'm losing, it's collaborative. And when I'm winning, it's strongly competitive. Combined with an element of, I've got to make sure that I am working on a different one for someone. So you see, someone in purple has just started working on this one, which would be nice. They're going to show us how quickly they can solve this one. So you get things like the 1 and the 3, and the 4. I'm being nice by not stealing it from them. If you want to join in, as you may have worked out that you can join in, since this is collaborative or competitive. Very nice, well done. We're in section 861. I picked a large number. The website is organised so that the 24 million nonograms are sorted by section. Some of the sections have been completed, some of them have not. We're down in section 861. That is you. I thought it might have been you from what you said in chat. There is a collaborative version of this, I suppose, which we've got 24 million of these to do, so in some sense it's faster if we work together, but we'll see. Something that's nice is, outside of like stream sniping, if there's a group of people, we can go look at the front in a second if you like. This is the kind of backwaters where we're in section 861, so who knows what's going to happen. But this is kind of nice feeling towards the start. Let's have a quick look. It's kind of nice feeling. So people have done the small numbers first. Not exclusively. Some people are doing the large numbers working down. They've got down to about section 977. But you see, I like the way the percentages look. So the percentage of completion is not 0 away from the front. So there's some attraction to working on the next section, working down. And then some diminishing returns where we get down to this kind of background thing, followed by just some random numbers that are doing quite well. And at the front, people have worked on the first 116. So if you go to sort of jump to this button, jumps you to the next unsolved one. This is a quite nice collaborative effect going on, where at the front, that's taking a while. At the front, there's already somebody working on that one, or is that me? Maybe that's me. Sometimes, I suppose, depending on when you catch it, there's this nice sort of collaborative feel of lots of people doing a thing together. You see somebody else over here, and somebody else has just done this one. So there's like about 5 of us around here, I think. And that's quite nice in a way. Oh, actually, it's quite stressful now that I've started working on this while streaming at the same time. Phew, okay. It's not a competition, but you sort of get, you can be competitive about it, I think, which is like the best things in life, right? So I can't decide if this is a good streaming idea or not. I sort of suspect that it's not a good idea, and I should get back to doing some chill maths, which is what this stream is advertised as. But first, how's everyone doing? Yeah, we could sort of pick our own. We could pick our own large number, right? I was in 861 a minute ago at random, but we could choose what would be a good section to claim as like ours, our small corner of the internet where we. Oh, I missed that 5. Sometimes you do a bit of puzzle and then you find a 5 somewhere and you think, oh, I could have coloured in that whole row immediately if I'd seen it faster. There, some 5s, and 111 I like because you can put the 111 in. 4 is pretty good. 4 tells you that the middle 3 are there. So there are these patterns, right? 111 you can fill in. 3-1 you can fill in, 2-2 you can fill in, but then the other one you can infer something straight away is 4, you can put something like that. 3, you can always put something in there because wherever the block of 3 is. And then the more subtle one is 2-1, you can put something there as a first step because wherever the 2 and the 1 are, you get a block there. And similarly for 1-2. So my kind of first moves are always to fill in bits and pieces based on easy bits, and then at some point brain engages and I have to actually think about how to fit in the rest of the numbers, or how the way that it's actually resolving into a grid. And then there's a step at the end where I think I'm just clicking to fill in the gaps for what I haven't got yet. So 4 goes there, 4, and then this 3 means it's not there, so over here, and then I haven't done 4 yet, but this 2-1 and then 3. And if you do these for too long, you get into a kind of, I think, Zen state of just clicking in boxes and filling in more and more of these. And there's a kind of infinite supply of them. So, good. Right. Where should we go for a chill maths area? This is not very chill because I feel like I'm competing against this lime-coloured one, which might be one of you. But we could claim a corner of the internet. We just need to think of a number between 1 and 1,000. And if people haven't done it yet, that could be ours. 950? I reckon 950 is a nice round number, so I reckon it might be done. Should we see? Is 950 done? 950 is not done. Cool, right, 950 is ours. Right. What's the Math 3D? What's going on? In chat, Mean Machine Rex says something about Math 3D. Is it like a new sort of Desmos that somebody's found? What are you up to? I'm jumping to unsolved puzzles. Oh, there's just one over here. I never know why sometimes people have done all of the ones around, but they've just left one out. And I don't know what's going on there. Sometimes it means it's extra difficult, but not always. So 3 means you can put a couple in the middle. Yeah, so we start there. Okay, good. I did stream about Galois stuff. It did not cause me to know any Galois theory, unfortunately, because it's actually quite hard to learn maths on stream, as you've noticed, if I've proved anything on my time on Twitch. Math3D.org. Oh, okay. Yeah, we should try that out. Okay, cool. How do I stop solving nonograms, though? Everywhere I look, it's just nonograms. When I close my eyes, it's just patterns of numbers. There we go. Right, good. Oh, well, right, okay. Somebody's having an exciting Sunday afternoon drive. Right, 1, 1, 2, 2. Go over that in first. What's this Math3D thing? Let's have a quick look. Is it new? Oh, it's a graphing calculator. What is this? So this is math3d.org, and it's got folders, and it's got surfaces, and it's got colouring, and it's showing currently this sort of saddle-shaped thing. Put in some other powers. Well, that's quite nice. Oh yeah, right, okay. What do I want to see? Let's see something like sine 1 over x squared plus y squared or something. Oh, it's doing the same thing as Desmos square. It doesn't close the powers and you have to press right arrow. Like that. Ooh, yeah, that was a bit mean of me, wasn't it? Quick benchmark against Desmos 3D. It's pretty nice. So I bet it does other stuff as well, though. Because Desmos 3D, I've sometimes felt like well, we had trouble with all the trousers, didn't we? That this was also really flickery, and it really struggles to render sometimes. But maybe this one, stuck them together. Maybe this would be more fun. I guess there's just something fundamentally hard about doing things like this. But maybe it's mean of me to ask it for these. Is it using some sort of? Is it the same as? Okay, it's just complaining at me. Squared on there. Yeah, okay. So you give it spiky things, it struggles, but that's normal. Yeah, this is sort of Sarlacc Death Pit sketch. Fun question is maybe what do you expect this to look like? I suppose we can use regular Desmos does quite a good job of this, right? Because regular Desmos can show us. What I'm trying to do here is things like sine 1 over capitals, sine 1 over x, but 1 over r for radial distance. I think the first thing I gave it was sine 1 over x squared. So regular Desmos does quite well at this. I suppose if you can call that doing quite well. It's a really hard thing to draw. But then in 3D you get all these problems of trying to resolve those, but also trying to put like surfaces around. So it's kind of not surprising that it struggles with this sort of thing. Let's be nicer then. Let's be nicer. Let's do something like this. Oh dear. So firstly I want that, and I want to put minus signs everywhere, don't I? A nice Gaussian thing? There you go, that's not very large Gaussian. It's too large. Still too large. Little Gaussian hill. Do I get numbers or sliders or anything? No, okay. Add object. implicit surface unstable feature. Obviously, I'm going to click that. Can I hide this? Yeah, I can hide this. Oh, crikey. Okay. Oh, so it's trying to sketch. What's that? A hyperboloid of one sheet. And it's having a go at triangulating it. It's really having a go. What's going on over there? There's something going on over there. Yeah, the geometry is really interesting. This is the default thing that just loaded in when I put in an implicit surface. So I presume if I change that to a different power, then everything goes a bit wrong. Describe that as a bit wrong, but not very wrong. Okay. Yeah. Good. Right. Okay. Yeah. It's not a disaster. Oh, right. Hang on. I've got samples. Oh, hello. Back to the death pit. Add object. Explicit surface. Oh, I clicked implicit. Explicit surface. Go to that one. Hide that one. Explicit surface. Let's do the sign thing again. I found a sample slider, which you don't get in Desmos. So that would be a good reason to switch. Because Desmos has often given me, Desmos 3D has often given me these kind of very flat red surfaces. This kind of translucent stuff's a bit nicer. Right, so samples. Oh, the settings! So many settings! Can I just crank these up? Or it gives me a loading bar. I mean, what am I hoping for here? I just pressed 0. Goodbye, stream. What am I hoping for here? That's pretty good. I'll press 0 again. Every time I press 0, I risk just destroying the stream, I suppose. Because all of my computer's attention goes from the stream into rendering this. Yeah, I think I've broken it. Possibly broken everything. Yeah, okay, killed it. But nice of them to give me a slider. That's what I'll do with it when you give me a slider. I'll put the settings at a number that is just a disaster for my computer. Oops, right, yeah, okay. We broke a Chrome tab. Not the first time we broke a Chrome tab, and probably not the last time we broke a Chrome tab. Good, right. That is cool shading. I liked that a lot. That was good. Before I killed it, I thought it was going quite well. What was that called again? math3d.org. I will bear it in mind for my next 3D surface, which is happening, I suppose, because I do teach that sort of thing to students occasionally. You know, sometimes you've got to give them examples of 3D surfaces so they can go and do things in 3 dimensions. Bless them. That's a 1, so that's a no and a no. Oh, why's this one got green? Oh, because it's done? And that's it? That's all of it? It's just like, no. It's gone green because it's solved, James. And that's all of it. That's all there is to see. Amazing. Yeah. Okay, right, I'm back in my puzzles now, aren't I? This is a bit of a problem. Okay, right, we'll do this for a second and then I'm going to go and do some maths. I think it is maths 22222 on screen, doing puzzle 23,739,248, possibly. Or maybe it's someone else. We are a nice round number now. So who knows who's at this point. I don't know. I'm going to steal this one. 2 on the left. 3 means you put these in here. 1 and 2 means you get that one. Fine, I already have that one. 2, 1 means you get those ones. Oh, it's time to think. Cross that because of the 2. 3, 1, 1 means go there. Tempting to think over here. No, 2, 1, 3 down here. 2 and a 1 means you stick this up here and that down there and this in here. Oh, crikey. Right, okay. Good. Let's switch over, I think. That was fun. And half of me does just want to solve these for the rest of what is this, a 2-hour experience? 2, 2, 2, 1, 4 at the front. But I'm becoming concerned that this is not good TV. This is just me trying my hardest to solve puzzles while also talking and struggling to do both. I'm not sure I can be entertaining at the same time. You were Tuck in the last Maths Club video. Tuck, yeah, that's all biscuit, isn't it? I called you TUC, I think, which is the trade union. Yes, it's biscuits. Yeah, so someone didn't recognise this one as a biscuit. There you go. See also Ritz Bakery. Right, okay, good. Hide that one. No update on t-shirt, I'm afraid. I mean, I've ordered the t-shirt. It's in delivery, but I'm not wearing it because it hasn't arrived yet. I'm expecting it in time for next week. We'll see. We're trying to do a t-shirt with the Gaussian primes on, based on a t-shirt on the UK, based on a t-shirt on the Enrich website, but using Gaussian primes instead of real primes, which is a step of nerdery that I'm obviously very happy with. One down here, two over here, so 3 means it won't reach this far, which means the 2 up here goes over here. That's then the 1 for next to this 2, and then this 1 over here means no, so I'll put that one in, and this one and that one there. Doing a lot of misclicks. I've been doing a lot of these on my phone where I think I misclick less. Maybe not, who knows? Maybe I'm just not coordinated when it comes to very small squares. Just mashing my thumbs away at anything I can click on. No, not necessarily. 2 and a 1. No, got that. 1 1 means this. 2 means that fills in there, and then think about this 2 2. Should have thought about the 2 2 at the start. Down there. I just feel like I could be faster. You know, when you find something where it's like, that was very quick over there, well done. You find something where it's like, oh, if I've been paying more attention to what was going on, I could maybe get slightly faster at this. It was like maybe just a tiny bit, we could do this even better, which is quite an addictive feeling. The sense that we could improve just a tiny bit. Maybe this is how pro gaming people get really into things, right? The sense that if you just did 10 hours of video games back to back, then you might actually get really good. Can't really say that I've had that for other things on computers. There we go. But maybe this is my thing. Maybe this is what I get really good at. Maybe this is the thing where it's like, oh my goodness, just amazing at nonograms. And then just as I'm getting, well known for doing nonograms without misclicking, he's like, wow, this guy can click on the square he meant to click on. Wow, clip it, amazing. Just as I get really good at it, will presumably be the point where we run out of them. There's a finite supply. There's 24 million, and once we've sold all of them, it's not interesting, right? It's not like chess where there's millions and millions of possible games. We've only got 24,976,511 of these before we're just done. Quite like the idea of being just done. Sort of puzzle scene where we have to give up because we've done all of them. It's quite tempting, to be honest. So, if every game of chess had been played, if they were all in the book and everything was book moves, then maybe people would not play chess, or maybe they would, because actually that's pretty true for chess openings, isn't it? Yeah, so that's the future we can dream of, where my addiction to this website is actually good? Question mark? Like, in a good way? Yeah, okay. Well done. You've got into my lane. You've got in my lane. I'm skipped down here. You can try and catch up if you like. Maybe I'll steal the left lane in a second. I've changed the zoom settings on everything so that I've got 3 columns because I think that looks better on stream. I thought about it. I thought, could this be a streaming thing? Could this be good? Right, okay. I shouldn't say these things, right? Because I know that in a second I'm going to switch back to reading a textbook about quadratic forms, and the claim that quadratic forms the quadratic forms make better TV is it's really stretching credibility, isn't it? Never knowingly undersold. Oh, you got this line right. Go over here. Could start a fight. Let's try it out. Where are you going to get down? Look, I'm safely over here. No, I've done the invade and I regret doing the invade. I don't think I'm going to win this. No, don't think I'm going to win it. Too slow by far. Oh, too far. You got it. Okay. Okay, right, good, right. That felt quite trolly, didn't it? Okay, let's switch to maths. I won the invade. Now we're switching. Okay. How's everyone else's week been? How have you been? Feels like it's been quite a long week. Quite a lot. We've been getting ready for the open days in the maths department, which has been a thing. That's set up there. What's everyone else doing? Machine Rex just says 2 vanilla. Possibly they want the quadratic forms, and I'm preparing to give them the quadratic forms. So I could interpret that as a wish for a very particular thing. Right, good. Okay. Is this going? Is this going to be on screen? Quadratic forms? Maths is coming back. What do I think of the new personal statement format? Oh, I have a meme for this. Or not a meme, but I have something. I found out some news, and when I found out the news, I thought of Twitch chat. I thought this will come up in Twitch chat at some point. We'll do it in a second. So personal statement format is changing for UCAS. You get 3 questions, and they're pretty sensible questions. They're sort of, why do you want to do this at university? What are you doing in school? What are you doing outside school? More or less. So I think they're fine. I think it's the sort of thing that people were putting in their personal statements anyway. From my point of view, maybe that's just an Oxford thing, but it was the sort of stuff that I think people are putting in their personal statements anyway. I've looked back at my personal statement, right, and it starts maths is the centre of my life, which I could absolutely write next to why do you want to do this at university, and it would be just as cringe. So I'm not worried about that. The other change they've made, which I don't think has got any fanfare, I don't think this is like out there, is that they're switching to UTF-8, I think. I'm not sure. This is more rumour level news, but they're switching to UTF-8, I think, which means that they're going to start accepting letters with accents. And also, because UTF-8 encoding includes these, also personal statements are going to support emoji. This is what I thought of when I thought of Twitch chat word like this. I don't think anyone's done any testing on this. I'm not sure it's happening this year in some sense, but something I've been told is that UCAS personal statements are going to support accented characters. Good news, accented characters, because they're doing UTF. And I heard that and I thought, I think that also means emoji. I think that also means emoji, right? Like it's like snowman emoji. Snowman emoji has, not this one. I'm trying to show you yeah. So maybe you can help me work this out. Snowman emoji, shown here in horrifying 3D, has a, there it is, there's the cute one, UTF Unicode character version. Can you see this little guy? None of this 3D thing, I'm talking about this one here. I'll zoom. Can I zoom? That's as much zoom as I can give you. This little guy. Does he do Twitch chat? You got UTF, is a UTF-8 Unicode character. I think he's now supported, which means that your personal statement could be this guy. There's a minimum character limit, so you'll have to put this guy several times, but this guy, there you go, yeah. I'm not sure. Okay, things I don't know. I don't know whether this is happening this year. I don't know whether anyone is going to test it by using emoji. I don't know whether UCAS have thought of this and they're going to remove all of the fun emoji stuff and they're just doing accented characters. But I am now looking forward to the question, which Matthew just put in chat. Oxford tutors, what do you think of emoji in personal statements? And that's going to be immediately turn into the question, which emoji should I use to strengthen my personal statement? Or are there any emoji I shouldn't use? Or what's the most common emoji that successful candidates use in their personal statements? You can do all these varying questions, right? How many emojis should I include in each of the 3 questions? It's like, we're going to get a whole new kind of Gen Alpha kind of range of personal statement questions. Nothing to do with the 3 prompts that they're giving people, just this switch to UTF-8, which is going to have, eventually in one scenario, is that People just get really keen on emoji. There you go. What's the most... Yeah, how can I stand out with my use of emoji? I don't want to use all the normal ones. I want to use this little guy. There's a 1% chance that somebody finds this clip, thinks that I'm not joking, and puts a snowman emoji in their personal statement. So I should maybe be careful. Not that that would be good or bad, but I wouldn't want them to lose any sleep if you're thinking about whether that's good or bad. Yes, I know I've made it where my Twitch emotes get in. What a horrifying thought. Imagine if you could use RFL, which is short for reflexivity, which is the thing you say in the natural number game. Oh my goodness. Right. Good. What are we doing? Something like last week we read a bunch of stuff. Oh, that's my desktop background. Ah, there it is. But tiny. Right. Get your magnifying glasses, chap. We're going to study the tiniest textbook. How small can I make the textbook? Oh, I can make it very small. I mean, it goes all the way up there, but that feels like the funniest size. Right, welcome back to Chill Postage Stamps, where we look at postage size mathematics. No, okay, right, I should resize that, but also I want to change the what command to more accurately reflect what we're doing. I should also change the title of the Twitch stream, but I don't really know how to do that, so I didn't change it before. So it just says Chill Maths. Chill Maths is the umbrella term, right? It's the brand of what we're doing. Right, I'm in quite a silly mood. It's the emoji in personal statements. I blame the emoji. It's just made me realise that everything is a bit silly. If you look at it too much, you're like, you guys have enabled emoji on personal statements. Cannot tell if this is reality or if this is a sort of Reddit post. But I should be sceptical about. Right. Shout out, by the way, to Obi-Wan Pez, who gave me a follow 7 days ago. And also to, I don't know if these are friends of Mean Machine Rex or something. Mean Machine Rex, you're in chat. You seem to understand Twitch much better than me. Academy of Useless Ideas and E to the 2i Pi. I feel like I've seen the usernames before. They gave me a shout out to their viewers on Twitch streams. If you'll hear from them, then thanks. They're your amigos. Hey! I've definitely seen E to the 2i Pi as a username before because I remember reading it and then thinking, that's one. That's very good. And Academy of Useless Ideas. I think they're both followers. Good. No, they're good. Okay, right. Is there a button I can do to shout them out? Is that a thing? Right. Now I've got to add. No, I've said that, and now I've got to try and do it. So I've been saying shout out, and then it turns out because they did it. Turns out that's a Twitch feature. It's a purple button, maybe? No. Is it a pink button? There are so many buttons. Is it safe to show people this button? It feels like it's safe to show people this. Add quick action buttons, stream markers, clips, stream information. Oh, that's a good one. That's how I might change the title. Stop raids, prevent incoming raids for an hour. As if you get, I don't know. Community has got like all these like predictions and streaming together and polls. We do some of that. Clear the chat history, amazing. Emote only chat, great. Safety, and then monetize. There are loads of monetize options. They're all green. Right. Okay. I can't find out how to shout out someone. No, I have a raid button, but I feel like that's different. I do need to learn more Twitch. I have several buttons, but none of them feel appropriate right now. Okay. Right, good. That was an experimental first half hour. Here's a game. Here's a fact about UCAS personal statements. Here's what Twitch looks like. Do you remember the olden days? So not far back to Galois theory, but there was a time when we were streaming and just everything Twitch was doing was weird. It was giving me so many like pop-ups. I had to turn a load of things off. It was just constantly trying to give me information during a stream when I'm already trying to do about two things. Two things: read, look at chat. Three things if you count thinking, and maybe we shouldn't. Yeah, trying to read chat. There was a big pause there for me to read chat, right? Because I was also, oh god, okay. And Twitch has also given me all these notifications. I'm not saying I'm better at Twitch, but I have got better at switching off Twitch. Right, is this working? Because this was giving me problems earlier in the week. No, it looks like it's being well behaved again. Wow, good. Okay, so previously on the show, we've been learning about these quadratic forms. I'm interested in what values a quadratic form can take because, well, if you rewind far enough, there's a really old math question where we generate some solutions to x squared minus 2y squared equals 1, and somebody on stream once, for work, asked me whether we'd generated all of the solutions. There's some method of generating them. Have we generated all of them? So I'd quite like to know how to characterise the solutions to that equation so that I can get back to them and say, yes, we've got all of them. But it's quite hard maths. What would I say to that now? It's that question I just posed, I just remembered. I suppose I would say, well, moving along the separator line, that there's some region of this binary tree. You draw this massive binary tree that we draw most weeks on Chill Maths, containing areas for all of the fractions. And in some of the areas, the value of that thing's positive, and some of them it's negative. And there's a line, we can prove it, a separator line between the two, which travels through the binary tree, turning either left or right as it goes. And it's periodic, because there's a proof buried in here somewhere that we saw to say that it's periodic. So along that line, you might see the value 1. We haven't got to the maths yet of whether or not you see the value 1. You might see the value 1. If you do, it's periodic, so you'll see it along there. And you won't see it anywhere else, because values away from the separator line are larger. So we've got this kind of story we can tell, as to say, you won't see it anywhere else, because 1 has to be next to... Can 1 be surrounded by... okay, moving away from the separator line, things get larger. Right, okay. Yeah, so this is a topology thing, right? In chat. If you make a shape small enough, then it's not there. So all shapes must be topologically equivalent, right? Because you could just make them all very, very small, and then none of them are there. And somehow this is not allowed. I think the moment where you shrink your torus down to a circle, so like you have a balloon torus. I'm going to stick my pinky finger out there. You have a balloon torus, and you remove all the air. So you get a circle. I think the moment that the surfaces touch, the moment the inner radius goes to 0, that moment is not allowed for topology reasons about what we're doing. And similarly, the moment where you shrink that circle, in chat you're proposing to shrink that circle down, I think the moment where it collapses to a point is not allowed. So there are some limits to what you can do to do with invertibility, right? Can I remember what a diffeomorphism is? Probably not. Yes, so you're not allowed to do these things, says Maths222 in chat. But I think there are 2 moments in your story that are not allowed. Yeah. Well, which moment of there's a proposed homeomorphism in chat, right? This is the discussion in chat now. There's a proposed homeomorphism. It can't be a homeomorphism because torus is not homeomorphic to a point. Is a fact that we know. But why isn't the proposed thing a homeomorphism? I think we could be quite precise about which points are not homeomorphic, which points in the sequence. Didn't say that well. Right. Okay. There was a request in chat for a poll for whip versus biscuit, and I didn't feel like I'd been following chat to know whether or not that was an appropriate poll to run. Can't always keep up with chat. You can't always know what they're up to. They're always up to something, though. Yeah, right, okay. We've also got the word genus on chat. Yeah, I see you all. Right. And I just need to revise, I think, from last week, we learnt some language, or we were looking at some words for these things. Yeah, I remember this. We had 4 quadratic forms, and we became worried that even... Our only trick is to look modulo the discriminant, and primes of the same remainder modulo that discriminant were turning up in different quadratic forms. Up to then, we'd only seen them appear in a single quadratic form, things that agreed mod delta. Oh, the whip was for me. Great. Okay. Lucky me. Right. And so there's some splitting down here between different forms. Equivalence class of Q3 splits into two proper equivalence classes, with Q3 having a mirror image form. And then the idea from Gauss there is that these things are a bit like I, or they're a bit like integers mod 4. You have this kind of circular behaviour. And there's a pair of complex conjugate numbers in there. That's how I'm imagining it anyway. Right, okay. Okay, and we haven't proved any of this. We haven't proved any of this at all, but we have got some justification for the principal form, which was defined ages ago. And we have got this rule about, we've got this general group theory that's coming up, being part of this structure is called the class group. Okay, I can do this. And then what was genus? If the numbers represented by two primitive forms cannot be distinguished by congruences modulo the discriminant, then these two forms are said to be the same genus. Okay, so if you've got numbers where their values are all represented by two primitive forms cannot be distinguished by congruences modulo the discriminant. Previous example, Q1 and Q2. Two different genera. Okay. I think we should read on and try and find some cases. The other genus, right, they're in the same genus as each other. I was a bit worried about that. Up here it says Q1 and Q2, and Q3 is different, and then I was waiting for the other shoe to drop in it for it to tell me the Q4 is the same. Because, right, okay. There is a kind of dimension thing going on. Primes that divide the discriminant seem important, and yeah, so we've got over here we've got 2s and 7s because we're looking at 56. In this case, it's very complicated. But there were previous cases where this thing formed the rule for if you see a prime generated in this quadratic form and a prime generated in that quadratic form, then the product is in this other quadratic form. Previously we saw ones where that rule for where to look behaves like C2 or C2 cross C2, which is a higher dimension if you like. Let's have a look back at those just to see. Not the 56 example, not the third level of complexity. I can take away the bookmark now. We've moved on. So taking away the third level of complexity. With this Klein 4 group, what was the situation? What was the discriminant for these ones? Minus 84. So 84 is 2s and 3s and 7s. So I'm expecting 3 dimensions, but excuse me. So where are 2, 3, and 7 made in this? They're primes that divide the discriminant, so they have principal forms. Like where they have, there's not principal forms, sorry. There are obvious forms that generate these things with 2 and 3 and 5 and 7. Oh no, these are all horrible. B squared 4 AC. Is the prime 2 still different? Yeah. Oh, Machine Rex was maybe when they said different dimensions talking about the separate topology chat that's still going in chat. It's funny how they overlap, isn't it? Or funny how you can reinterpret questions in different contexts. Interviewers for Oxford are unlikely to talk about algebraic topology because they've probably planned what they're talking about beforehand, and it's not reasonable to expect candidates to know about algebraic topology. This shouldn't stop you from learning algebraic topology. For me at least, I like to ask similar questions to several people. So if some of them have read a textbook about algebraic topology and some of them have read a textbook about, I don't know, topological algebra, then it's quite hard to make a bespoke question for each person. Also because, unfortunately, even if you love algebra topology, you still get admitted to the same course. If you're applying to the Oxford Maths course, let's say, then the first year is the same for everyone. So in some sense, having this sort of justifies having questions that are designed based on the course rather than questions that are designed based on the candidates. Anyway. Oh yeah. Right. Doing the work stream by mistake. Right. Okay. Yep. Okay. Wait, is Ginger 222222 like a kind of pseudonym because of like ginger biscuits or something? Is this like, am I reading too much into that? Or am I reading exactly the right amount into this? There's a sort of maths biscuit pseudonym. Oh, ginger bit, there you go. I thought about it exactly the right amount. Possibly I remembered because we talk about that sort of thing around here, don't we? Good, okay. What was actually going on here then? So where do you actually see 2, 3, 5 and 7? I thought they'd be in nice simple forms, but then I realised that, oh there, I've circled them already. 2, 3 and 7. So this one got 3s and 7s. That's not crazy, is it? That's not crazy. Because, well, look at the form. Can this make the number 7? Yeah. Can it make the number 3? Yeah. Those things multiply to be a quarter of 84. Viz 21. Not a massive surprise. It feels like the number of twos in the number seems important. Maybe not. Maybe that's what the mod the discriminant is doing. Because I've got this divide by 4 step, which I'm kind of interested in. Where you get this 21, we get this 21 written like this. And then you've got this really complicated form, which gives 2, and the value 2 over there. I'm kind of interested. I do sometimes. Mat Livestream, we've just started Mat Livestream, so it's like a new project. So they're new. When something's just started, I'm trying to promote that as a thing, right? To say you should come back for more Mat Livestream, rather than trying to immediately funnel people into Chill Maths instead. Because I think if you're clicking on Mat Livestream, then you've got a particular sort of thing that you're interested in seeing, and it might not be this. Me gazing in a vague manner at binary trees covered in numbers, maybe this is what mathematicians do, right? Maybe this is what mathematicians do. Binary trees covered in numbers. Ooh, 55 and 75, you say? That's a very interesting binary tree. Right, okay. Yes, I'm also very worried about that. I've been doing the other way round too much. That Chill Maths has been too aware of Mat Livestream. There was a time, I think, where Chill Maths was less aware of what I was doing at work. Is it going to be a problem? You're not all going to turn up at the open day, are you? I mean, you're welcome to come to the open day especially if you're interested in applying to maths at Oxford. But is this going to be a thing where people start turning up? No, it's not that big a thing. People are going to turn up. Right, okay. You all know. Yeah, okay. Right, okay. Yeah, not the other way around. I don't know about your work. That's right. What does everyone else do? That's so rude of me. I've been streaming for like a year and a half. I have no idea what everyone else does. Or did you mean the other way around, that work don't know about what I do? Right, okay. Okay, we've got a principal form, which I think is this one, which acts like the identity. It makes the number 1, for example. That's a good start. And then it also acts like this. So if you're looking for a power, so if you find a prime in one of these things, like the prime 3, I think we're being told that powers of that prime appear in there as well. I can believe that. It's not too hard to make them, is it? Keep y set at 0 and put 1 in here, or I can make 3 cubed by putting 3 cubes in here. How do I make 9 though? Can I make 9? No, I can't, can I? Because 3 plus 7 is 10. So there's some numbers I can't make. Okay, interesting. So, yeah, okay. So you've got some restrictions on which numbers you can make. Anyway, for primes not dividing the discriminant, you get these rules. Let's see. I'm still just trying to revise what we were doing last week. Whoops. Revision is good for us, though, isn't it? Right. Can I make? So I can't make 9. Oh, right. Okay. And maybe I'm not allowed to make 27 because I'm not allowed to stick 30 in because I have to put coprime numbers in. Never appear with the exponent greater than 1. Okay, and that's a much better rule. I like that a lot better. Rather than trying to find 9 or 27 in that picture, being told that they're not there, I'm up for that because that's an easier message to take on board, right? It's a difficult idea that you might be able to find 9 and 27 over there and over here, but this is instead telling me, whereas can never occur with exponent greater than 1 means they're not there. We haven't proved any of this, but it's easier to keep track of. Might be the sort of thing we should mess around with. I'm sure the textbook's going to get there in the next 2 chapters. So, what is that, 4 or 5 months of my life? But the next two chapters are probably going to prove this. But it might be something to mess around with, to think if you have a quadratic form, it seems that we're being told ax squared plus bxy plus cy squared with discriminant b squared minus 4ac, and we're being told it can't take the value, and with some divisor of the discriminant. So given all of that, we're told that ax squared plus bxy plus cy squared equals d to the n for n greater than 1 has no solutions. Seems like the sort of thing we could mess around with. Don't quite know what we would do. You can make d, you can't make d to the n. I mean, you can only make d if you take the right values of a, b, and c as well. There's only, well, there's infinitely many choices, but only one equivalence class that can do it, I think. At this level of complexity, we've discovered some questions that we would like answers to. Right, okay. Right, here we go. Okay, third level of complexity, things got more messy, didn't they? Because in this case, this is the one where, there are 3? I thought it'd be 4. Is this one not a mirror image of itself at all? But it has a mirror image Q4. Right, so it's not a mirror image of itself, so you can imagine a flipped version, Q4, and that's Gauss's idea, to split it into itself and a kind of reflected conjugate thing, which I think comes by just putting a minus sign in front of xy in the quadratic form. You get the same discriminant, but you get something that is not properly equivalent. Right, okay. It's almost a cup of tea, isn't it? People are putting their drinks orders in chat, ready for the 5 o'clock break. Okay. Troublesome form Q3 is different, does not have mirror symmetry, so it splits. I love the idea that your number might be made. So Q3 and Q4 contain the same numbers, but we're going to get really into these like rules about where to find a number. If you can find numbers in 2 different quadratic forms, then there's a third quadratic form which makes the product. We're going to get so into that apparently we need to split between Q3 and Q4, even though Q3 and Q4 here take the same values. Gauss says that we should split those apart and think about them as 2 separate things so that we can have nicer rules about where to find things. I think that's a bit crazy, isn't it? It's a bit, I don't know, it's a bit like you've got a filing system, you're looking for some stuff, and somebody says, no. The reason you can't find stuff is because there's no logic here. You need to take that file and split it apart into even more files. then you'll be able to find stuff. Okay. It's Gauss rearranging my office. Off you go. Right, okay. Oh, group visit to a pub, right. Okay. It's nice to watch Twitch just sort of glomming together into a sort of band. Oh, you should make a band. Right, okay. We always end up in this place of me versus Twitch, which is an interesting dynamic, isn't it? Something I'd quite like to bring back is, well, to be honest, I'd like it if somebody else brought it back, but something I might have to bring back in the future is Maths Jam. Maths Jam is maths in a pub. It's for people over the age of 18 in the UK, and it's like a maths communication thing, but you just sort of turn up and have some maths puzzles or fun or whatever. It hasn't run in Oxford since the pandemic, and ideally I'd like someone else to run it and set it up and run Maths Jam, but I'm aware that if I think about that enough, then eventually I will realise that I need to set up Maths Jam and run Maths Jam. Not sure I need that job right now, but yeah, it seems like the sort of thing that, just by talking about it on Twitch, I might become self-aware enough to realise that it has to be me who does it. At the moment, I'm sort of naively just like, oh, maybe someone else will do it, and I'll just go to it. But as I say, eventually I'll think. Then I'll have to do it. It seems fun. Right. Okay. Okay. Then the rule about multiplication, but this is still like an example, so I think it's time to move beyond things that we looked at last week. Just before the break, we're going to switch down here and read about Dirichlet's theorem, primes in arithmetic progressions, which is close to some of the best maths that I think is out there. Do I think that? I sort of made that opinion up midway through. Not sure I put much conviction into it. I'm going to try it again, but with my enthusiastic Instagram voice, which is Dirichlet's theorem is some of the most impressive maths in, I think, all of maths. That's my Instagram voice. Right. Twitch is censoring words, probably in chat rather than censoring words that I'm saying, so I'm going to ignore that. Let's hope it's not Dirichlet or theorem, because I'm going to have to say those loads of times. Let's go. Primes inserting congruence classes. So you've got an arithmetic progression, and you're looking for primes. Oh, yes, please. Primes modular congruent to 1 or 4. So apart from 2, which is a very strange prime, primes congruent to 1 mod 4. Other possibility is this sequence of primes 3 mod 4. Such sequences form arithmetic regressions for fixed positive integers a and b. Oh, I've got my sound off. Such sequences form arithmetic progressions. Okay. Are there infinitely many primes? Dirichlet says yes. They should be co-prime. Fine. I think this came up on... Where did this come up? I've got a feeling this came up on Magic Squares on Maths Club, maybe? Yeah. And there is a video with James Maynard talking about this. Is that on Numberphile, or is this just James Maynard on a different channel? Which one have you seen? Let me know. Infinite many prime square, whatever A and B, both. Of the idea of Maths Jam. Let's know. Just stop talking about Maths Jam, otherwise I really will have to do Maths Jam. You can't just talk about not running a thing. It's too much of a dick move, isn't it? To just bang on about how a thing currently doesn't exist without offering to run it. Okay, we're not going to prove Dirichlet's theorem in this book. Chat, we're going to have to read another book at some point in our lives to work out the proof of Dirichlet's theorem. And here we go. So we're going to do easy proofs instead. Okay. Simplest case, version of Euclid's proof. Off we go. Ooh. Something strange happened, but I've come back. suppose there are finally many, multiply them all together and add 1. Brill. Does that just work? Does that just work? That's amazing. These are all -1 mod 4. Yeah, this is the one that works perfectly. No, that's Euclid's algorithm. Well, you could put the number 4 in here. There we go, down here. That just works because this new thing is -1 mod 4. So it must have a prime factor that's -1 mod 4. Otherwise, all of its prime factors being 1 mod 4 would get you to something that's 1 mod 4. You can multiply by 1 as much as you like. You are not getting to 3. N must have a prime factor like this. Yep, okay, Euclid. Down here, this doesn't work for 4n plus 1, which is the ones we care about, so that's a shame. And also just the fact that there are infinitely many primes and there are infinitely many that are 3 mod 4. You'd think that you could put those two facts together in some easy way, but no, sadly you can't just mash those two facts together without thinking about primes. Anything could be possible. Yeah, -1 plus 1. Here we go. However, the quadratic form can be used. Ooh. We will show that for each discriminant delta, there are infinitely many primes represented by forms of discriminant delta. When it's in the case of -4, there's only one form like that. So infinitely many primes represented as the sum of two squares. Oh my goodness. We're going to prove something. Yes, please. We will show that for each discriminant delta, there are infinitely many primes represented by the forms of this. Infinitely many primes represented by this. So we're going to prove that this takes infinitely many prime values, which is not quite what I want, because what I want is that it takes all of the ones that are 3 mod 4, 1 mod 4, sorry, all of the ones that are 1 mod 4, not just saying that it takes infinitely many of them and all of the ones it makes are 1 mod 4, because once again, that's an infinite subset of an infinite set, and it's knowing whether it's the whole thing or not. These infinite sets. You can just fit them inside each other like Matryoshka dolls, but it's not clear if the Matryoshka dolls are actually getting smaller or not. Infinity. Such a disaster. Right, okay. None of these can be 4 minus 1. Yep, okay. So we're going to show that there are infinitely many primes of this one. Are we maybe later going to prove that there are infinitely many? Oh, yes, and different discriminants give you different flavours of this argument to get you different numbers of different congruences on primes, different arithmetic progressions. Euclidean algorithm. Wait, hang on. Okay. Same reason. For this one's got discriminant 5. It does infinitely many primes. Methods in the next section will show that the primes represented by this one with this one cannot be more specific about which one it is. Because it can do both. Okay. Fancier forms of the Euclidean argument that can prove this, but they don't work for the other ones. Okay, fine. So this is just telling me some proofs are going to fail if you take them too far. Fair enough. Right. Okay. Just in 3 quadratic forms. Proposition 6.18 provides other examples for each discriminant of class number 1. But don't we feel like there's not that many things with class number 1? Not that many. I think at least one representing infinitely primes. However, there is another hard theorem of Dirichlet, which does say that for each primitive form of non-square discriminant represents infinitely many primes. My goodness. Okay. So this class number 1, I'll double check it with some sort of Google search at some point, or flipping through this book, but I think there's not actually that many. So this is a nice thing that we've just skim read, might not go that much further. Okay, right, time for a cup of tea or a glass of water or whatever. I'm going to run an ad break. If you're not shown any adverts for some reason, the screen will say back soon. You might like to draw this quadratic form. I think we're actually going to move on to the next section, but you might like to draw this quadratic form, thinking about values less than 100 that it takes, because that's a question. We usually skip the questions, but it's tea break time. Right. Tea break time. So I'm going to go. I think I'm going to get a glass of water for this one because it is really warm. Really warm. Right, back in a minute. See you in a minute for some more maths. Right. I'm back. It's faster. I'm just kidding. Didn't have to boil the kettle because it is so warm. It's like I'm in a boiling kettle. Oh my goodness. Right, okay. Is this the hottest day of the year? It feels like it could be the hottest day of the year. It's probably not though, is it? Right. This is more like what I've been talking about. How's everyone doing? Thank you to Murray for the tea time redemption. You spend points. Some people have got tea, I think, maybe. Did you get tea? So, oh no, right, well, blimey, okay. Hang on, can I like... Wait. I can't work out how to refund the points. No, I can do this. I'm great at Twitch. No, who knows where they might be. There's some button for telling Twitch whether or not I did my Twitch challenge notification alert box settings. Oh, yeah, there's a hydrate button. I forgot about that one. Because we mostly just use the tea time one, don't we? Everyone remember to drink some water is a different one. To be honest, I've forgotten what I've set up. I should probably have a look back at this again. I remember it being quite fun to set up, so maybe I'll go and do that. Oh, we have Gigantify an emote. That's like 30. Can I have a go at that? That sounds fun. Oh my goodness, okay, get started. Gigantify an emote. Okay, brilliant. And then I pick like RFL. And then I send an enormous one. And it comes out normal sized in the... Comes out normal sized. Oh, it's big. Okay, right. I can see why no one does that. What does on-screen celebration do? I've forgotten we had these. Does it do anything that's visible up there? Unleash celebration? Will it do something here? It did nothing. And I've highlight the messages. Highlight the message is like 128 points. Oh, these things are like bits. This is why no one does them. These things, I don't know. Ah, right, okay. So then I should scroll down to the things you can do with zero-dimensional channel points, which is highlight a message, which is not very highlighted up there, and unlock a random emote, which I don't know what that does. Choose an emote to unlock. That's it. You can have sub-only emotes, and I don't even know what they are. The animated ones? Who knows? Twitch stuff. Isn't this nice? Abrake came back early from the outbreak, and then I wasted all of your time by mumbling about Twitch again. Here we are. What a stream. Representations in a fixed discriminant is maybe exactly what I need to hear, because I don't really care about x squared plus y squared. I want to know if it takes infinitely many primes of the form. No, I want to know if it takes all of the primes. I want to know which values it takes. I'll accept which prime values does it take, because then I think I'm off to the races. But it sounds like in a few sections or something we'll see a proof that it takes infinitely many prime values, which must be 1, 1, 4, so infinite many primes 1, 4, 1, 1, 4. I'd like to know whether it does all of them. That would be nice. I think we've been told it does, but we haven't been shown that it does. Right, okay. No, it's not what's actually going on. The problem with determining the numbers represented by a given form is difficult in general. So, easy question of determining which numbers n are represented by at least one form of a given discriminant without specifying which form it will be. But that's okay, because for discriminant minus 4, there's only really one form. Right, representing n in discriminant delta is a phrase that I should use. A form Q represents number A if and only if Q is equivalent to a form like this with leading coefficient A. To see this, note first that this obviously does represent A, and any form equivalent represents A. And then conversely, if a form represents A, then A appears, and by a suitable transformation, you can bring that over to the 1-0 thing as if you brought it over to a different representation. You can transform to bring that region over. Okay. So if you think it might take the value A, you can start looking for ax squared plus unknown coefficients for the other two. Yeah, right, good. My Madam Mary, chat's now. Chat's leaning into the antagonistic thing that we had briefly. Right. Now we're all in this together. We're against the quadratic forms. The quadratic forms are the enemy, with their devious splitting ways and their resistance to telling us which values they take. The function, I would like to know which values it takes. This seems like quite an easy question. If I plug in all possible inputs, what outputs will I get? I'd like to know the image of integer pairs under x squared plus y squared. Why is this a hard question? Maths. So us first is the maths, right? Good. Okay, have I got them back on? You got half an That's what you're getting for the James Rage. Right. Okay. Together. Onwards. I felt the people moving against me. Together, do a rousing speech. Right. Okay. Yeah, this is a good fact. I like facts like this. Even number n is represented in discriminant delta, and so is every divisor of n. Let's see if I can guess how this is going to go without looking at the screen. So if it's represented, then I guess put it on the first coefficient. Now what? So now I need to change this somehow to get, I guess I'm aiming to change the first coefficient, but keep the discriminant the same. So multiply up c and get a value that does this while keeping the same discriminant. Yeah, multiply up. Okay, right, good. Let's read the proof. If we find which primes are represented, and then which products of these primes are represented, we're done. Okay, good. That is nice. If n is represented by indiscriminate delta, then there is a form like this. That's what I thought. If n factors like this, then you can move the n2. This is the thing that was hard to imagine in my head. But if this is n1, n2, you can move the n2 over here and keep the same discriminant. Excuse me, because b squared minus 4ac will be the same. It'll stick those n1 and n2 back together again. Chat has not responded well to the rousing speech. Chat has heard the rousing speech, the togetherness message about everyone being on a common cause, and chat has heard that and has got together and selected a common cause. Unfortunately. Okay, that one wins. That one wins. That's perfect. We're all getting banned in 3, 4, 1. It's just that really takes the biscuit. Right, okay. Oh my goodness. Right. Don't make me do another rousing speech. Right. Okay. Which ones have we not used? I've got to be impartial now. Hobnobs. Don't think we've had hobnobs yet, have we? They're great though. OT biscuits. They're brilliant. Right. Let's see if that lands well. Famously, people talking about biscuits is always unifying. No one has ever been ostracised for biscuit choices before. Right. Yeah. Okay. Right. Good. Okay. Oh my goodness, Twitch. Right. There's probably a reason why there aren't. Probably a reason why it's easier. No, this is why we do this. Right, okay. I think I did this one in my head, so I was quite happy because I moved the n2 over. Let's see what we do the next one. Okay, simple congruence criterion for when a number is represented in a given discriminant. So proposition 6.2, there exists a form of discriminant delta that represents n if and only if delta is congruent to a square mod 4n. A square mod 4n. This will be because square is making me think b squared minus 4ac. So square mod, there's the discriminant delta that represents n if and only if delta is congruent to square mod 4n. So if you can make n, put it as your first coefficient. If and only if there's a form like this, and then 4n. B squared minus 4nc. B squared minus 4nc would be delta. So delta would be b squared more than a multiple of 4n. Yeah, precisely. Okay, good. Mod 4, mod n. Yeah, okay. Since Q is like this and it appears in the topograph. Oh, this is not the proof I thought it was going to be. Shall I write down mine quickly? Maybe, maybe not. So mine is something like nx squared plus bxy plus cy squared has delta equals b squared minus 4nc. So delta is a square mod 4n. And conversely, if delta is a square mod 4n, tell me which square, and I will write that down as b, and now tell me what the multiple of 4n is, and I'll write that down as c. And then I'll get discriminant delta perfectly, and I will get the number n over here. Right, okay. Suppose n is... Okay, right, so what are they going to talk about then? N appears in topograph. Look at an edge of the topograph bordering region n, then we take an equation like this. We should use this fact, right? We just had this fact of moving it to the front. Anyway, same idea. H is the label on the edge. Where does that come from? H is the label on the edge. Yeah, but then there's this form turns out to be equivalent to that one over there. So I think it's the same. Which is their preference of talking about the topograph. You get that one. Conversely, conversely they're going to do it my way, I think. H squared is an integer times 4n, so it's this for some k, and then put that down as the value of c. There you go. Then you get that one. And conversely, I think it's just never mind. Okay. Let's see what this proposition implies about representing small numbers n. Okay. For n equals 1, it says there is a form of discriminant delta representing 1 if and only if delta is a square mod 4. The squares mod 4 are 0 and 1. Discriminant forms are always congruent to 0, 1, or 4. There always exists a form that represents 1. Well, this is quite a good fact, so let's just reread this fact as a fact rather than a challenge. There exists a form of discriminant delta that represents n if and only if delta is congruent. So if I'm interested in minus 4, there exists a form of discriminant minus 4 that represents any number you like, if and only if minus 4 is congruent. Minus 4 is congruent to form of discriminant minus 4 that represents n, if and only if minus 4 is a square mod 4n. That's not obvious at all, right? Whether minus 4 is a square mod 4n. Is it? Feels like it might be obvious. Is minus 4 equal to b squared plus 4nk? Well, these are both even, so b would have to be even, and then divide by 4. Is minus 1 equal to different number b squared plus nk? This tells us, is minus 1 a square? Oh wait, hang on, this is good. Is minus 1 a square mod n? Which is also a fact I care about a bit. Is minus 1 a square mod n? Is there a number such that b squared is 1 less than a multiple of n? Right, and now this is good because now this is asking us about numbers of the form b squared plus 1 rather than thinking about x squared plus y squared. There's a flip here to thinking about factorizations for the numbers b squared plus 1, which I vaguely remember from the last time we tried to read about this. But there's this, yeah, okay. So actually applying this, you've got to read everything twice, right? Once as a kind of challenge where you think, well, that doesn't sound true at all, and you try and work out why it's true. And then separately you read it again, if you're doing it right, which I don't always do, but you read it a second time as begrudgingly accepted truth that might be useful for what's about to happen, right? Why have they said this? Where's this going? So my application is sort of the number minus 4 is one that I care about. I get to minus 1. Is minus 1 square mod n? Which is a good question, right? We all know that minus 1 is a square in the complex numbers. We all know that minus 1 is not a square in the real numbers. But what about these modular arithmetic worlds? which of those have -1 as a square number? For example, mod 5, that's a world where -1 is a square, because 2 squared is -1 mod 5. What about 19? Because 19 is one of these. I've said that really confidently, and I regret that because it's not true. 17 is one of these worlds where 4 squared is -1 mod 5. Hello, Stam 3333333. That's a very precise number of threes. Welcome to chat. Good to see you. Oh my goodness. The setup, the punchline. You could at least follow. Right. Wait, what's Stam backwards? Wait, what's 1 less than 2222222? Oh my goodness. Crazy. There's a chance I'll read it out if you follow. Right. Right, okay. Thanks, at least you're ready there. Thank you for the follow, Stam33333333, who I'm certain is a different person from Maths 222222. I'm certain. If you haven't met before, I think you'll be great friends. Right. Good. Yeah, there you go. You've got to switch between 2 things now. Oh, look, you can do both devices. You can do both. You can have them both going at once. Let's see if that conversation's going anywhere between those 2. No, too much effort. Too much effort. Right, okay. Good. We've just had the brilliant realization that we can understand which numbers you can make of the form x squared plus y squared by thinking about which numbers have -1 as a square. It feels like we might have to learn about quadratic reciprocity if this goes on much longer, but had trouble with that before, haven't we? I think now many years ago we tried to learn about quadratic reciprocity and it was really tough. Good. So, what are they going to tell me then? About representing 1, I think you can always represent 1 by using one of the principal forms. There it is. There's the principal forms. Good. In the case n equals 2, the possible values of the determinant mod 4n, which is 8. What is this? The possible values of the discriminant mod 8. Oh, I've got really stuck now. Are ones that are... No, whoop. Back it up again. Here we go. If and only if delta is congruent to a square mod 4n. So then what are they telling me down here for case n equals 2? Because I know that the discriminant has to be 0 or 1 mod 4. I'd forgotten that. B squared minus 4ac is always 0 or 1 mod 4. So these possibilities are the things that are 0 or 1 mod 4. And here are some squares, and these lists don't agree. The number 2 is not represented by any form of discriminant delta. These lists do agree. They have 0 and 1 on both lists. Do I care about 0? Maybe. I care a little bit about 0, don't I? It's a square. Let's read on. 2 is not represented by any form of discriminant delta. When delta is 5 mod 8. Right, because we're talking about when 2 can... Gosh, I'm trying to piece it all together all at once. 2 is not represented by any form of discriminant delta when delta is 5 more than a multiple of 8. But for all other discriminants, so not that one, but all the other ones, all the other possibilities of what the discriminant might have been mod 8, there is a form representing 2. Explicit forms representing 2 like this are this, which is multiples of 8. This form, they say it's got discriminant 8k plus 1, and I believe them because of the plus 1. And then this one has got discriminant 8k plus 4. And those are these 3 cases. And there's kind of a bit of generating the squares going on as well here, right? With the 1 coefficient here, 0 or 2, which is increasing through the values of b, and giving us values of b squared, giving us squares. So I think these squares will always be... So I need these lists to agree, and the things that are 0 or 1 mod 4, they might all want to be squares, but the squares are always 0 or 1 mod 4. So the squares are always on that list as a subset. That's the case for mod 8. Do I want to refine that idea to think a little bit more? Squares are always 0 or 1. So yeah, no, that first list has been restricted down to things that plausibly could be squares. Or if you like, it's things that plausibly could be discriminants. But that's the same restriction. Things have to be 0 or 1, mod 4. Okay. Right now, 3. Feels like we should just check them, right? We should just do these. Yeah, here they are, with the different values of h in the middle for h is 0, 1, 2, and 3. And then, so these can take the value 3, because look, you just put 1, 0 in, and they take the value 3. Discriminants can be like this, but the squares are just these. I feel like listing the squares is a bit easier, isn't it, than listing all of the things. So I have to concentrate really hard on 0 and 1 mod 4 over there. So here are some things. Excluded discriminants are just therefore. Okay, so the kind of interesting ones that are kind of possible discriminants, which is why they're on the first list. Possible discriminants because they're 0 or 1 mod 4, but excluded because they're not squares mod 4n. Delta has to be a square mod 4n. Which for the x squared plus y squared case turns into saying, or indeed anything with even discriminants, turns into a statement about, well, you can divide by 4. So you can talk about things being square mod n. Right. Okay. Oof. What is the strangest thing I've seen in a personal statement? It's probably maths is the centre of my life, which is the first sentence of my personal statement. I think that is still the strangest thing that I've seen in a personal statement. Has anyone done anything really weird? No, not really. Yeah, I think I might be the most cringe anyway, if that was the question. Yes. Has anyone ever sent you your personal statement? No, no one sent it back to me. People have sent me feedback on my personal statement, unsolicited. Even worse, right? It's very earnest. Let's go very earnest. I can't think. Yeah, nobody's done anything that mad, right? It'd be nice if someone had done something, I don't know, like only writing it in capital letters, or only using words that had the same number of letters as digits of pi, like 3 letters, then 1 letter word, then 4 letters, which would be something like, yes, I know, A, and then I want to get to personal at some point. The statement should probably have more letters in. Anyway, like the what's that poem called? The Raven or something that does this, where each word has a different number of letters based on the digits of pi. It's not the Raven because that would be 3, 5. There's a poem out there that does this. Constrained writing. Should tell the Maths Club people about constrained writing. Oh, we did. We talked about Georges Perec, didn't we? A Void, which is a book without the letter E. Right, okay. Keep going. But this is not really the question we want to answer, which is, yes, this is like the inverse, the other angle of looking at things. In the table of here are all of the forms and here are all of the numbers, I'd like to know for a given form which numbers can you make. At the moment we're looking across the rows rather than down the columns. We're looking at, for a given number, which forms make it, or which discriminants represent it. Because we've mixed all of the forms together into a bucket labelled with their discriminants, which I'm fine with because the one I care about only contains that one. Same case for x squared minus 2y squared, I think. That's got, yeah, there's nothing else going on there, is there? That's just fine. How else would you make that number? I'll think about that in a moment. Okay, there is more work to be done before we would have the sort of answer we want. Nevertheless, the representability criterion in proposition 6.2 is the starting point. Our approach will be to reduce the representation problem in discriminant delta first, the case of representing prime powers, and then to representing primes themselves. Okay. So, first step. Here we go. If two chi-prime numbers m and n are both represented, then so is their product. We've talked about this for the sum of two squares, because we had some nice formula based on complex numbers that showed us if you can make two co-prime numbers, or just any numbers, how do you make their product? So there was there was some rule last time that I think we called the Fibonacci rule. We should prove this though. We're going to be able to make this. Okay, is represented by discriminant delta. It's just a case of being able to make its prime factors. If a number x is a square mod m1. Okay, so we're doing a lemma first, and also a square mod m2. Oh, we're using that fact from before, right? Then x is a square mod m1, m2. We really care about which things are squares. These quadratic residues have just suddenly come into the picture, and they're all really important now. Fine. Maybe this is what quadratic residues are for. One of the many things that quadratic residues are for. Here we are. I wish more questions said warning cliche question coming up. No, not really. People are welcome to send me questions that they've sent me before. What's the best personal statement you have seen? Ooh. I like the ones that tell me, I like the ones that show me that someone's actually sort of keen on maths, which they all are, but to different extents. Occasionally you can really see it, that somebody really likes maths and has quite a clear idea about what maths is like. But this is quite nice to read. It's not really a selection thing. It's just, that's pleasant. This person has thought about maths. I'll take that over the people who have more of a, and there's nothing wrong with them kind of, I mean, I'm encouraging it in a way, but the kind of pop maths stuff, which I do like. I mean, I produce some of the stuff. Also this isn't pop maths, is it? But the kind of pop math stuff is nice, and it's how lots of people get into finding out more about maths. And I've got a lot of time for that. There's nothing wrong with people putting this in their personal statement or reading pop maths books, but occasionally people take it a little bit further, or they go a little step to, I read this thing and also I did this thing. I like it when people do that. Yeah, I know. Feels like pizza, right? Would I write about this on my personal statement? Would I say I've been reading about representations of quadratic forms? Probably. Probably would. Probably would. Let's write about several things, I think. Although for me it's not good, is it? Because I don't think about this when I'm not doing it. That's not true. I think about this when I'm not doing it. Right, okay. How does this even work? Oh, it's just an application of CRT. also square mod m2. And there are numbers that work like this. So we just need to solve this pair. Can't I just multiply them? No. I need to solve the congruences to find something that is equal to A1 mod the product and also equal to A2 mod. No. Something mod the product that is equal to A1 mod M1 and A2 mod M2. There it is. So then it squares right. This implies that, since the difference is divisible by M1 and M2 and a coprime, so we're good. Coprime. Okay. So then 6.3, which is saying if you can make M and N and the coprime, then you can make Mn, and this is going to be short down here, 6.3 proof. All right, okay, slightly harder than I thought. At least one of them must be odd. If they're both represented in discriminant delta, then delta is a square mod 4m and mod 4n. Hence, also mod n. What? Hence is doing so much work. What is going on there? Something about fours, something about one of them being odd. Oh, yes, odd. N is odd. So if you're a square mod 4n and n is odd, then you're also a square mod n. What? Oh my goodness, that's just, it just sounds like soup to me, in a way. I just need to write it out. I'm being silly, I think. Yeah, no, I'm being silly. I'm just being silly. That's still mod n, isn't it? It's b squared mod n. It's b squared mod 4n is b squared mod n. So you take the same square root you were going to use and square it. Okay, fine. Why are we talking about 4n then? Why are we saying you must be a square mod 4n? Ah, whatever. Okay. You can't go the other way? You can't go the other way. Right, you can't go the other way. Since 4m and n are coprime, so it's like cheating, right? If I use the fact n is odd, no. Oh, I am now. Since they're coprime, delta is square mod 4mn, so the product. So mn is represented in discriminant delta. So this felt like we wanted to use the fact to say delta was a square mod m1 and mod m2, but we needed to not gain an extra factor of 4. So we just threw one away. Not at random, but I don't understand what n being odd. Oh, because you need to get down, you need them to be coprime. You don't want the 4 at the end, and you don't need it in the method. In the middle, you want the things to be coprime. So you need to be sure that you've got rid of enough 2s to be left with an odd number. Okay, that's a little bit messy. That's a bit of a mess. Still, it's 20 to 6. It's a very warm Sunday afternoon. What's this factor of 4 business? I sort of follow each step, but not. And I sort of have an idea of why we've done it, but I'm suspicious now of the previous fact, which we've been talking about squares mod 4n. And we had this idea, didn't we, for the particular quadratic form x squared plus y squared, where we're interested in discriminant minus 4. The idea is to divide everything by 4. Divide everything you see by 4. So what's going on? Why are we talking about this mod 4n business? Well, of course it's not the same thing. Mod n and mod 4n are different. You might be a square. Which way around is it? If you're a square mod 4n, you're definitely a square mod n. But if we just go out there looking for squares mod n, then some of those will not be squares mod 4n. Because when you move up to the 4n world, your square might, well, you might not get that. You might not get the right answer. You might not get something between 0 and n. Moving up is always impossible. Right. pause here. Mean Machine Rex has gone for dinner, I think. Mary is gonna be quiet until I'm chill, which somehow it's got a big chill sign. I'm trying to understand primes. Is that not chill? I don't know. Oh, right, okay. Maths 2. I don't know if they're working on a personal statement or something, but they're quite keen to ask about personal statements that I enjoy reading, which is probably 0. Sorry, everyone. Probably 0. I don't think they're too long, but you might read an application and get to quite a lot of text in the personal statement. I think, I'm scrolling through applications, like I've already seen this person's GCSE scores, their predicted A-level grades are in here. I've got this big chunk of text, so I'll sort of have a look to see what's there. Right, secretly. No, okay. It's a trap. Possibly other universities or even other subjects are doing more of a. Other subjects at Oxford maybe are doing more of a review of personal statements, possibly giving them scores or something, or possibly putting them all together in a big score. I think I'm happy with the way the maths currently looks at them for information, but doesn't try to score them or say whether they're, was this information delivered in a way that was enjoyable or good or correctly enthusiastic or used the right number of emoji or something. I think I'm happy that we're using personal statements for information rather than for. Let's be careful. Let's say mostly for information. With I think the number of times that a personal statement for Oxford Maths, the number of times that has an impact is dwarfed by everything else. Anyway, right. From Mr. Freeze. Oh, we never quite got Ice Cube emoji to catch on, did we? We never quite got Ice Cube emoji to catch on this thing. Oh, because I didn't make it into an emote. Let's go to, and I didn't. How many books? No one's going to count, I think. I mean, I'm not going to count. Other universities might count. Other tutors might count. I don't know what number they're looking for. And joking aside, I'm more interested in how people have used books, or what, if you've mentioned a book, what you're trying to tell me, or, now that personal statements have got these questions, I think it's interesting which question we might talk about books or reading. Because there's, depending on subjects, there's some reading that you do as part of classroom stuff, and there's maybe some reading that you do just because you're interested, and there's some of that, maybe a third category where you did it because you did it for the personal statement or you did it for the application, which ideally you would also have a good time and maybe it would help you get your A-levels or whatever. But I think there's this kind of category of reading which is pretty tough. I'm trying to model good behaviour by going through and actually trying and stopping and thinking about stuff. I could read every word in this book in not a single stream, but what would it be? It's if I just blasted through looking at every word in the book, I think I could even read it out loud in 4 or 5 live streams, something like that. Just like 10 hours, just blasting through. So on the show, trying to model this behaviour of like, I don't know if I'm going to get to the end, but I'm going to learn something along the way. Okay. Chill Maths Ice Cube. Draw a cube, making a note. Right, okay, got to draw a cube. Larry says I've got to draw a cube. Oh, that's not bad, is it? A bit long, bit of a long cube. Let's bring that last. It's going quite well. Bring that last one. That's too much. Bring that last one back just a tiny bit. Clear. There, that's a cube. Cube. Ice cube. Oh, let's label it ice cube. Okay. So that people know what it is. Not very good E. There. Perfect emoji. Do I colour it in? Or does it just stay? I think not coloured in. There's your emote. Now I've got to export it, haven't I? Oh, right, okay. We're still talking about squares. It's now all going to be square numbers, isn't it? It's all going to be squares from here on in. Sorry, it's just okay. That one. Oh, I think that probably killed the stream. Did that kill the stream? Ah, who knows? Oh, I thought I'd take a sneaky screenshot with my incredible handiwork. Just make my life easier later. Ha 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 ha. Didn't work. Possibly broke everything. Maybe it just paused all the graphics going to my screens. Who knows? Okay. Okay. So it's this co-prime things joining these together. But we want to make prime powers. So is this lemma going to tell us how to do? What is this then? We're making a distinction about odd primes, which makes me very nervous because I've been worried about factors of 2 already in this one episode. If number x is a square mod p for an odd prime p not dividing x, then x is also a square mod p to the r for each r greater than 1. Moving up is hard. The corresponding statement of the prime p equals 2 is that if an odd number x is square mod 8, then x is also a square. And then you can keep going from 8 upwards. 2 is such an odd prime. Okay. For example, 2 is a square mod 7. So 2 is also a square mod 7 squared. Like this. It's also a square mod 343. So likewise, it must be a square. It's also a square mod 343, so you can go from there. Oh, this is telling me about the thing 2 to the r? No, what's this telling me about? We're talking about prime powers. So 2 is a square mod 7 cubed. Oh, 2 is not. Is 2 a square mod 7? Oh my goodness. Is 2 a square mod 7? I'm mixing up all my primes here. Why are they telling me about 7 cubed? Likewise, it goes up like that. Because 2 is a square mod 7. Method of refining the initial congruence like this. Why are they doing this one starting at 7 cubed? Oh no, we're just still going. We're at 7 squared, 7 cubed. Right, 7 4 7 5. Okay. A method for refining this to each subsequent congruence and so on. For the prime p equals 2, we have to begin with squares mod 8. Since 3 is a square mod 2 but not mod 4. Mod 5 is a square mod 4 but not mod 8. Right, so it's demonstrating that you can't go up a power of 2 sometimes. Okay. Right, we've got to get from being a square mod p to the r to being a square mod p to the r plus 1. Assuming r is large enough. Where large enough has a different meaning for number 2. Okay. By induction, we will prove the lemma. Here we go. Right, off we go. We begin by assuming that x is a square like this. Here it is, x is y squared. P to the r divides x minus y squared. So it's like this. What are we looking for? We are hoping that you can put another prime p on here. Interesting. For some integer l. We'd like to find a number z such that this is true. So it's reasonable to look for a z with z equals y mod p to the r, so that it's reasonable to look for this, so that at least it works mod p to the r, and then, whoa, are you going to get lucky? What's it going to be? Mod p to the r plus 1. Because there's only p possibilities or something. So check all of them maybe? Let's see. In other words, z is this. Oh, yeah. Check all of them. You don't know what to put for k yet, but we're going to check all of them. Maybe just they're going to tell me what k is or maybe not. We want to choose k such that this thing, x is a square like this. And there's k of these, so it kind of feels like we've got enough degrees of freedom to pull this off. In other words, we want p to the r plus 1 to divide x minus all of that this can be rewritten like this, and then there's going to be some, yeah, this has got a bit wonky, hasn't it? We've got this p to the r, and we've got this, and the thing that we really want, for this to be divisible by p to the r plus 1, p should divide all of this. It does divide that bit, because r is greater than or equal to 1. So then the question is whether p divides this. Can you do this? Which is a nice linear Diophantine equation. Always has a solution when p is odd. Perfect. So we don't actually work out what k is. I feel like we've seen a version of this somewhere else before. You can go up to build your prime powers. Lovely. When p equals 2, the argument breaks down the last step. Since the equation L like this becomes this, we'll not have a solution when L is odd. To modify the proof that it works for p equals 2. We'd like to get rid of the factor of 2. So, well, we're going to solve this because in the case p equals 2, we've also got that r is greater than or equal to 3. That just makes this term more a factor of, more a multiple of 2. Suppose that instead of trying this, we try this. Ooh, which gives us more options. Down here. So down here, this gives us just enough stuff down here. This is a bit brave to try this thing with 2 to the r minus 1 instead of 2 to the r. Assuming r is greater than or equal to 3, which means 2 should divide that bit, and then we're good. And then we're good. So then you get a solution, Bazoo or something, to actually find it. Cool. Oh, thanks for the follow, Math Dork. Good to see you. If you're new here, welcome to the Chill Maths show. I'm trying to read a textbook very slowly and out loud, and I'm trying to stop and think about it. Twitch chat is up to all sorts of business at the same time. Twitch chat occasionally. Hello, what an intro. Twitch chat occasionally joins in with the maths, and occasionally builds things or stops me and asks maths questions, or asks me about other sorts of maths as well. I've done all my intro, but of course I've got no idea whether you're a new person or if you're the same as one of the other people. We've had some repeated users today. Hello, Fenvox fan. Good to see you. I'm about to stop. I've got 5 minutes. Right, okay. Best personal statement ever. Oh, right, okay. Alien Machine Rocks. Good to see you. Right. How am I going to do 6.6? Let's find out. So I feel like we've seen some of this before. We're getting onto some more sort of beaten track number theory. I read some number theory on stream a year ago or more, and it was a bit of a mess. And now some of it's coming back to haunt me, isn't it? Look, is it a square mod p to the r? And the way this proof goes through all of these different things. I like Math Dog. Welcome to the show. Right. Yeah, okay. So we read it once as a challenge. The first time round, you're skeptical. You're like, this doesn't seem like it could be true. Why has it got all these different cases? What is all of this necessary? Then we read the proof, and then before we move on, we have to try and begrudgingly accept it as now being a true fact that we can use later on. For example, I think we're about to use this, combined with our understanding of quadratic forms, to say something like, if you can make, but no, the mod there was in the mod. We've got this fact to say, yes, we've got this fact to say that delta must be a square. Is delta a square mod 4n? We've got this big question: can you make n using some quadratic form with discriminant delta? And that question has boiled down to asking whether the discriminant is a square mod 4n. Which, now, we've been looking at recently prime powers, because I think we're going to say if you want to try and make a number n that has a large prime power in it, then this question, yes, we're splitting this apart. We're saying look at the prime factors of n and try and argue about them separately. I think 4 or 2 is going to be important separately. 4 or 2 should be, yeah. I think they're we've got this extra rule about the prime 2. I'm really worried about this factor of 4 in our fact, because if it was just n, I would now just go, right, we can stick these together. If you can make prime powers, you can make products, then you're good, because delta will be a square. If you know it's a square modulo each prime power, and you know it's therefore a square modulo the product, but then there's this factor of 4 as well. I need it to be a square mod 4n, which is slightly harder than being a square mod n. I've got confused about that today, because you can go from one to the other, but not the other to the one. Right. Hey. And then we met on the summer school, and they told me in person that something I'd said on the stream was wrong. How did you meet the other people on this show? It's nice kind of like summer school power move, can we call it? If you turn up to a summer school having looked up the speakers and all the mistakes they've made, so that you can come prepared. But I'm going to meet these people. I'm going to point out. No, you were lovely about it. Right. Yeah, it's 3 o'clock. To be fair, I was very wrong. I was very wrong about how many holes a thing had. Not quite as bad as the t-shirt one. Can we find the 3-hole mug? Let's see if we can find the 3-hole mug. Is this a search that I'm going to regret? Yeah, this one. This one. So it's this Reddit post from a couple of years ago, and I think my new position is that I don't know how many holes this mug has, because it kind of has one for the handle, and then I've got really concerned now about how many. Yes, it's a hollow thing punched through. This was my mistake. That if you put a second handle inside the mug, that would give it a second, the genus 2. But then the thing I hadn't realised on stream and had to be told in real life is that no, it's a hole that you can see through. So a third thing going on there. Normal handles of mugs are not hollow. I mean, maybe they are for actual mugs, but not for topology reasons. Good. So it's 3. How many holes? It would be hard to clean, especially if you look straight down in it. It's got the bar across. But I was so confident that the bar across was an extra handle, that you could pull it out and it would be an extra handle. And I was so confident about that I missed the fact that it's a hollow handle, or if you prefer. Yeah, it's not some extra solid material, it's an extra surface with its own. It's been pinched around to form this. How do you make a tunnel? You have to make the walls into a mob. Good, right, okay. I found that on Reddit. I'm not sure that's precisely the mug, but maybe it is. Also lots of bowling things, because bowling balls have got 3 holes, although actually they've got none. Topologically, a bowling ball is just a ball. Which is quite sad, isn't it? Any other good facts down that line? Can we get a video out of this? Topologically, a bowling ball is just a ball. Topologically, tennis is pretty interesting, because look at the rackets. Wow. No, that's not landed. Topologic, loads of holes. I'm thinking loads of holes. Topologists watching tennis. Yeah, okay. Other sports that are ruined by topology changes. There's the video. Sports that are ruined by diffeomorphism. Am I saying diffeomorphism or am I saying homeomorphism? We'll look it up before we do the video. Yes, please. What's the difference between diffeomorphism and homeomorphism? preserving differential structure, and I'm not certain I want to do that. I'd just say homeomorphism, I think. Which sports are ruined by homeomorphism? I suppose all of them, because you can make the, if it's football or something, you can make the football really large. Or you could make the holes in the back of the net really big so the ball goes through them. Well, that's fine though, because that's still a goal. You can make the goal really small and the ball really large. I'm just scaling though. Where can we go with this? Other sports. Yeah, so the question is, which sports, it's going to be all of them, but which sports are ruined by homeomorphism? E.g. bowling, not real holes, so just ball. You know, topologically, those aren't real holes, so by homeomorphism you could turn it into this. A bit like how your breakfast is ruined by homeomorphism because your mug turns into a donut and a donut turns into a mug. American football, because you can smoothly deform it into a normal football. Oh, you've got the animation as well. Let's play the animation while we're doing this topology chat, which is nice and chill. Is this logged me in? This has logged me in, which I'm not cool with. Open video, new tab. Still logged me in. Okay, we're not doing this today. Do picture of it. There you go. Can you do it very small? There you go. There you go. That's nice, isn't it? 3 holes with the extra one. Oh, there's a step in the middle that's quite hard to watch. Ugh, yuck. Lovely. Rugby also ruined for shape reasons. If you think the shape of rugby ball is the thing going on there. Oh, but rugby, interestingly, has this bit, like a lot of goals, are that shape, right? So we can do something with that. These sticky up bits. Yeah. So homeomorphism or whatever ruins this because we can make these very small, and then it's very hard to see what's going on because you can deform those to be smooth around the outside of the rugby goal posts. Not a sport I know the words for, but there's got to be a good one, right? Like sport with. Do they do any sports with donuts? Not really. Ooh. Throwing discs, frisbee. Do they have a hole in the middle for frisbee things? If so, then I don't know. I'm just going to make it larger or smaller, aren't I? But sport with where it's really important to have your laces tied, because then, ooh, is that actually tied or not? Not theory. Let's go. Cross country, you're just going around in a big loop. So, yeah, maybe this is not. It's not landing, is it? It's not quite worked. Unless I get one really good example where we deform something involved in the sport and it turns into something totally different. What sports are there? Yeah. Oh, hey, if you were just watching an ad, we've changed to talk about. We're just talking about diffeomorphisms, I think. It's been years. No, flying pancakes for frisbee. Yes. It's bubble bump. Is that a sport? Swimming feels like there's something in there, or maybe diving. No, these are all kind of the same on the transformation, or as much as anything is. The Olympic rings, are they actually linked? Are the Olympic rings ruined by? That could be a thumbnail, right? So the Olympic rings are linked. So the thumbnail could be some sort of copyright okay version of some defamation of those 5 rings. Because if they're linked, the defamation has to keep them linked. Okay, there's some legs on this. This could be a kind of stupid maths video. Like, I've ruined some sports by replacing equipment with things that are topologically equivalent. This tennis racket is now a really big pretzel with loads and loads of holes. This bowling ball is not. It needs a third really silly one, but I haven't quite got. It'll get there. I haven't got a donut shaped thing as the kind of punchline in the middle. And then tennis. Yeah. Oh wait, what was played with the Taurus? Bubble Bump is played with a Taurus. What on earth is Bubble Bump? Oh, it's the thing where people get inside those massive absorber balls and play football or whatever, but while wearing an enormous toroidal sphere thing. That is a Taurus. Yes. Okay. Okay, good. So do we ruin that? I mean, it's already ridiculous because they're wearing the big... It's a person inside a big sphere with their legs sticking out so they can run around playing football. That would be ruined by really many things would make that not sensible. I mean, it's already not sensible, so it would take quite big changes, I think, to make that into a sensible sport. Good, though. I like it. Yeah, would just be... You could just have a donut. Just have a donut instead. Yes. Good, right, okay. Thank you for teaching me what Bubble Bump is. Not sure about the name, or... It's missing like some sort of like equestrian thing where actually if you think about it, a horse, if you really think about horses, then don't do that. Sorry, Math Talk, ages ago I missed your message. I missed your message about baseball. Twice. That's really rude of me. Baseball's a great suggestion. What are baseball mitts like? I don't know what baseball mitts are like at all. Baseball mitts. They got a lot of holes. They have got a lot of holes. Maybe. No. But they do. And so there's a hole. I never know with gloves. Can you turn it inside out? If you can turn it inside out, I mean, you probably can't for an actual baseball glove. But some of them have got holes. Some of them, the fingers are a bit stitched together but a bit separate, which would be a collection of holes. And making them larger would be relevant to the sport, right? So if you change it so the kind of gaps between the fingers. Oh, sorry for Math Dork, I had a great suggestion and I didn't read it out. Now I'm really thinking about baseball. At the moment where the baseball and the bat... Yeah, maybe it's going to be something about a sport where you have to run around a circle. Like in baseball, you have to go all the way round the bases. But in my topological deformation, I can make that a very small loop, not zero-sized, but I can shrink that. So there's this class of deformations I'm using quite a lot where you make things larger and smaller. But I didn't know, I do like the kind of rugby, American football sort of one, where you have a ball. The sport is ruined by not changing the size of the object, but by changing it to something topologically equivalent. Ruined in the sense that it's now not American football, it's got a spherical ball now. Oh, cornhole. Yeah, cornhole, right? That involves throwing things into maybe a box with a hole. Nice. Yes. Although, so that one actually, yeah, because it's a box with a hole in the lid, isn't it? Like a guitar might have a hole in the lid. I don't think you make them out of guitars, but that's what I'm thinking of. Because topologically, if you made them out of rubber, you could... I think it's going to be topologically equivalent to a circle, because I think you can peel it back, right? Peel it back to get the hole in the top wider and wider until you've just got a circle, which, if you make it large, it's really easy to hit. But the point of cornhole is to try and get the beanbag. You throw a beanbag into the hole. I think it's called cornhole. If I've made that up, that's quite bad. Yeah, no, I didn't make it up. Good. It's not always a box. If it's not a box, then it's just a... If it's not a box, it's a board with a hole in it. Okay. Yeah, goalposts. Yeah, so the goalpost one I like. I like the goalpost one where it sort of shrinks, the top bits come down. Oh, no. American posts look like this, don't they? Which is then topologically equivalent to loads of things, but not having those. Changing the size of goals feels quite easy. Yeah, okay. Okay, good. Still thinking horrible things about horses, which I shouldn't share on the stream. Oh my goodness, the inside of a horse? Could you turn that inside out? If you turn a horse inside out, that probably ruins this sport. I shouldn't have said that on stream. Badminton, yes. No, rackets. Rackets are going to be good for a kind of punchline. This baseball mitt. I've got to think more about this baseball mitt. Yes, lots of games. Golf is ruined because that's not like bowling. Golf is ruined because that's not a genuine hole that goes all the way through the earth. That's actually just a sort of dimple that we could topologically make flat. So golf, I think, also ruined by homeomorphism. Oh, I can't believe we hadn't thought of golf yet. Yes, and billiards. Depends if you put a little bit of net underneath, and then net is very interesting topologically. Golf is totally ruined by homeomorphism, I think. Good, right, okay. I think we're going to call it there. Been nice streaming with you all. Even the bits where Twitch rose up, movement against me, despite my heartwarming speech about togetherness, or maybe because of my heartwarming speech about togetherness. I'll try not to do that again. We've got we're going to call it. Did you say golf ages ago and I missed it? I've got to do better looking at chat. You did train me for 2 hours. People trained me not to look at chat, and then sorry I missed you, golf. Right, good. Okay, calling it there. Next time, we've seen a proof that wow, we're going to try and build our prime powers now. So here we go. If a prime p not dividing the discriminant is represented by a form of other than every power of p. This idea you can make every power of p. And using that coprime fact that we had before, using the coprime fact to just glue together these propositions to make something new. So it's quite hard to keep up with all of this, but we're building quite quickly here some understanding of which numbers you can make, which is what I want. If I redeem tea time next week, depends how hot it is. I think that's the first time I've not come back with tea. No, that might be a lie. Right, okay. There is a hydrate button as well. If you want the illusion that you're declaring precisely which beverage I will enjoy during an ad break. Right, okay. I will have fun at the open day, and I will, I'm sure, see some of you on Matt live stream under our work personas. But I'll be back. Am I back next weekend? Let me find out. Because I'm sometimes not. I'm back next weekend. I'm back forever. This is what I do. I don't have any other plans at all until, what's that, like October? No, I've got plans. I'm going away in October. Okay, right. Yep, I haven't got any days. I haven't got any days out. Just streaming all the time now. Here we go. See you around. Enjoy your maths. And as Herb tells me to say, I am ending the stream now. Bye.